Welcome everyone to a little bit IT update here, some more series or so. Topic, of course, YouTube live streaming stuff still doesn't work on my main machine, so it's ridiculous. Also, apparently not the only problem. First of all, I had significantly less views overnight, and there was also some spike of problems. I don't know, maybe that is related or not. Whatever, internet, which brings us also to the topic of this video, which is amazing IPv6. And this amazing book I purchased new first 10-20 years ago. So literally this is printed in 2019. At least I checked here a second ago. And I brought this 20 years ago because in 1998 IPv6 was near and the next big thing, and IPv4 to be switched off. And I prepared to be on the frontier of technology, IPv6 20 years ago. And yeah, I wonder actually how much is deprecated and what changed in between. So it's still in our office supply here, but we still don't have IPv6. And I wanted to give a little bit of a shout out, so this will be a short video. I only wanted to say, so actually it took 20 years ago, right? IPv6. What is the big change? Of course, 20 years ago, it was already foreseen that we will run out of IPv4 addresses, which were 32-bit or still are 32-bit. And IPv5, by the way, was some work in progress, something existed shortly in experimentation or something. IPv6 then, also here's some kind of typo, in December 1998, intended to be replaced. Because here they write 1998 became draft and subsequently ratified by the IETF on 2017, so something of the dates doesn't end up there, but who's proofreading Wikipedia? Anyway, so the big change is 128-bit addressing. You would think this is not too much of a big change, right? Just makes those address fields larger, four times the size, and not a big deal. Also, then the addresses are printed hexadecimal instead of the decimal numbers that we usually use, and abbreviated with colons there. So if you have a lot of zeros in the middle, then this is so not a big change. You would think easy peasy, you implement this in 1 year or something, add support to a couple of operating systems, just makes the sizes larger and whatnot. But boy, could you be wrong. Of course, they had to change a lot because certainly you need to reinvent everything. So this is maybe also the reason why it didn't caught on. The problem is also then networks. You need the network address translation to or routers and whatnot to tunnel from IPv4 to IPv6. Probably one of the reasons because why this didn't caught on in 20 freaking years. And So from 1998 to the last 15 years, I did not even have a chance to have IPv6, right? So in Germany, unless you were a big company or something, private customer, small business stuff was IPv4, right? So no IPv6. It's only then with this cable shit, they had here some, the last years already IPv6 natively with some carrier grade NAT on their side, network address translation. So, but this had huge problems because first of all, I could not even open some sites for whatever reason, and streaming video was super slow because all the video streaming went from all the customers through their carrier grade NAT there, certainly overloading their NAT servers there. So I opted out of this relatively quickly after I realized after 4 weeks or something, I realized why does some stuff always not working. I analyzed this and okay, this IPv6 carrier grade NAT stuff sucks a little bit. And it's only since 1 year that we finally have IPv6 natively, but we are not freaking using it. So since 1 year, every other quarter, I think now it's finally the time to switch to IPv6. And each time I take a look, since every other quarter said, okay, this needs to be possible to configure, right? It's, I don't know what is wrong with all the software. It's hilarious. So today I tried out this example. Each quarter you Google this, like, okay, IPv6 can't be so hard, right? there are so many problems. First of all, this somehow all of the software is somehow outdated and not. Here are some patches, there are some patches, and also somehow each year another software version appears to be trendy and the latest and greatest. So each time I take a look, I find something else with Google. And fun fact, just today I added 2 packages to Tier 2, just IPv6, like this here, like this DHCP. The problem, of course, the Linux kernel is doing IPv6, not a big deal. The problem is this configuration stuff around it, and it starts already with DHCP, maybe our configuration here. Of course, we have the dual stack, right? So we get with our business line here, the failing cable docs, but business line, we get a fixed IPv4 address and a whopping huge 56 or something IPv6 segment that we can't even use because we can't configure it. And each time this stuff doesn't work. So for example, here, RHDVD. But it starts already. Historically, the software package R8DVD. This is some routing, something advertising whatsoever daemon. And then the question is also, because I followed here those guidelines and usually nothing works. I don't know what is wrong somehow. It starts already here. So this example, you would think, okay, fine. Interface Ethernet 0. Here's some send IA, what is it, request non-temporary address, an A non-temporary address, prefix delegation address, and so you see there is not like DHCP, and so you have some temporary addresses and prefix delegation stuff, and somehow always everything goes wrong, at least on my side, and and DNS servers and whatnot. But the problem is also already here, so they have here some nifty stuff. So ID associated PD1, the PD1 apparently says this prefix delegation stuff as far as I understand it. Prefix interface is 1, so that gets some custom unique prefix here. And then already this didn't compile. So first of all, we didn't have this running an unsuccessful one-man Linux distribution, right? So we didn't have this package here in T2, because why not? DHCP 6C. In the meantime, we have already also probably 8 DHCP daemons, right? Because you can never have enough DHCP daemons and clients and whatnot, because one is large and the other small, and this doesn't work, and somehow everyone needs his own DHCP client stuff. So this didn't compute here. So I packaged this from the official upstream sources there, where you would package this, and then you run this. First of all, didn't even give me error message, but nothing happened. Run it with strace, figured, yeah, okay. Tries the config file in another place, fine, move to config file there. Run it again, still no error message. And then, right, I had the DHC, also no error messages, right? Okay, it's meant to be run from startup scripts, but can still print something to standard error, right? You need to strace it and look into your system messages, but whatever. Okay, fine. Then eventually, after 3, 4, 5 runs with debug verbose and foreground and whatnot, figured, hey, this amazing software doesn't understand this IFID1. Googling this, of course, as usual, your favorite internet search. And yeah, it turns out this is some Debian patch, because, and then Debian people accusing me, here, look on the Debian patches, not making this shit up. And then you wonder, why does this not work for me? Yeah, when distributions have all their 20 patches, which, okay, only 19. Yeah, but I don't send my stuff upstream, right? It's hilarious. So yeah, of course, this is here patch 7 adding IFID option, which of course you can't apply because it conflicts with other stuff. Also, totally annoying. Here's some GNU libc fixes, which is hilarious if it would load. And so this is also renaming a whole bunch of, why does it rename this dprintf to debugprintf? Then you can't just cherry pick the 7 option patch, because that needs obviously this chunks of patch already pre-applied. I mean, it's hilarious. And why is this not upstream, right? These patches are 4 years old or 3 years old, and this is not upstream. Why? And okay, fine. I tinkered around with this, and bottom line is, after wasting 2 hours of my day, still not working. I've actually no idea why. This is really sad. You could say, okay, it's your own fault. I know from the dual stack stuff that on our home router that we also already opted out already, their IPv6 work with macOS. I mean, yeah, of course, it's a serious operating system, right? Not this, well, peak bugs, but whatever. And I've honestly not tried this with Linux probably, would not have just worked anyway. But yeah, so I now when I plug in macOS, but I certainly don't want to plug in macOS machine in our DOCSIS business line. But yeah, how is it possible after so many years that this is still such a cluster fcheck nonsense here? And leave me in the comments below. Are you using IPv6? And if so, which configuration? And if you use this with Linux, well, first of all, those citizens out there of the internet running macOS or Windows, yeah, probably it works for you, right? Running a proper operating system. But why what is even the market share? 80% market share of servers. Well, on the server, maybe it is a different thing. Maybe it's this DHCP thing and neighborhood discovery protocol stuff and advertising, root advertising stuff. The funny thing is also, so now I have this theoretically running, patched a little bit, but it works a little bit. Really strange stuff also. So this original DHCP thing from, which is that even, didn't show my IP address again. DH client, from which organization would this have been bind to something, whatever, you get the idea. So that one you can just run with IPv6 with -6 option. But this is also strange that this DH client doesn't, so it negotiates a prefix, which also, fun fact, you need capital P, I think, for prefix negotiation. You also wonder, enable IPv6 prefix delegation. I also always wonder, why do you need so many options? Can this not, but whatever, okay, fine, I want some 56-bit prefix something, but fine. But the thing is also, it doesn't do something with it. I mean, what do I have this prefix locked in the system log, but it's not doing something with it. I mean, what good is a prefix that it negotiates there? It throws away and does nothing with it. It's hilarious. And yeah, this other thing is at least setting some temporary address or what this was here. But also, when I run this DHCP-v6 thing, client thing, wait a second, is this even the, why does he write here configuring DHCP-v, okay, fine, anyway, because the program is DHCP-6C, confusing names. But, so when I run this, I don't get the default root, which I also, so you think, here they write, this RADVD was used historically. Do you still need this for neighborhood root discovery or not? The problem is also, you Google, you always find something else, right? You one tutorial is that, one tutorial is that. The Linux IPv6 tutorial is of course super long. I mean, good luck reading this, and I can also read this book, which is also already outdated. Probably as outdated as this, but of course this tutorial is like until you get somewhere. When we first language and terms that, yeah, okay, we know them already, and addresses, and okay, fine, it couldn't be any more boring and stuff, and at the end you still don't know much more, and it still doesn't work. But yeah, and then also stuff like, yeah, root discovery should be automatically, yeah, but doesn't work for me. Like if it gets some root authentication something stuff. So yeah, can't make this up. I wish I would have IPv6. Why do you think I even bother? Well, first of all, of course, we run out of IPv4 addresses. Second of all, after 20 years with this book, I really would want to see it working here. But third of all, it also would probably be nice for some IPv6 customers to have a native IPv6 address for some email server or other kind of server stuff. And last but not least, my hope was that if I maybe get here dual stack IPv6 going, that maybe it improves YouTube streaming here. Maybe not, you never know. Maybe this goes to some less saturated IPv6 servers. Was my hope, but yeah, I will probably continue to, well, maybe tonight or something, because I really finally would want to have this running. And again, leave me in the comments below, have you ever seen IPv6 natively on your side? Are you using this? And if so, with open source, with what clients? And the problem might be even that this one of those here, is it this one? Not really sure if it's, because the problem is also there's a fork of another fork. The problem is also sometimes that some of those tools are from the BSD world, and somehow they often, like here this came DHCP v6 snapshot of something, And somehow you think those infrastructure projects are totally amazing, maintained, people work amazingly together, but I've somehow, especially with IPv6, but also with IPsec, actually the security extension for IP, was this also came or something, there was also some OpenBSD stuff imported to Linux. Somehow this was always the same experience, not working by default, patches here, patches there, that broken. And yeah, it's I also don't understand why this really, with so many eyes, 1,000 developers, 10,000 developers, with the big distribution shipping something, maybe I should actually install a virtual machine with Red Hat or Fedora or something just to take a look what happens there. But yeah, maybe this stuff is also too complex, right? Because this is with more auto discovery and advertising stuff and whatnot, that yeah, obviously it's more than 128-bit addresses and some of this automatic stuff usually. Yeah, and the open source packages. Somehow not the most amazing experience. Yeah, wish I could just say IPv6 is amazing, just works, but somehow, yeah, somehow there's always something, and I really wonder why in 2019 this stuff is not just you configure, make, install, and yeah, 20 patches, some tutorials, and still doesn't work. So yeah, wish I would have better news, but can't have good news each day. So leave me in the comments below what you think about the situation, and maybe there should have been an earlier switch, right? I mean, we are really on the last IPv4 addresses. They are now on a waiting list for those who still need one. And apparently some universities still have huge chunks from some 40 years ago when they still handed out huge amounts of blocks there that are actually returned. And the only reason we have not run out of addresses 10 years ago is because these huge address blocks are recycled. But maybe they should have really made a switch like, hey, we really switched this off in 2008 or something, and until then people had to have migrated because somehow this dual stack and tunnels and stuff, I don't know, somehow not amazing. Hope to see you soon, and good hacking.